All right, we are dealing with simple equation. Simple equation. This is a very good example of simple equation. Any equation that has an equality sign here is known as equation. If you compare it to this second one, this one is called an expression. Why is it an expression? Is because there is no equality sign in it. That is, there is this symbol is not in this. That is why it is regarded as an expression. This is called an equation because it has an equal sign in it, an equality sign in it. So if you label them generally, this is x, which is the variables. Usually in simple equation, especially equation, we are expected to find the unknown. Usually the x here is the unknown. This is called the variable. Means it can change, can take any forms of number at the end of the day. Then you have the operator. This is the operator. The positive sign here is called the operator. It can be minus, it can be multiplication. All of this is called the operator. Then you have the constants, which is the number here. This is also regarded as a constant. But this very one, because it's not having an equality sign, it is regarded as an expression. This one is called expression because there is no equality sign in it. In this equation, it's going to take several forms. And at the end of the day, we are going to be finding the unknown, which is the x. For example, if you have things like this, you have x minus 7 equals to 10. This is an equation. What you're looking for is this x, the variables, which is the unknown. Now what you need to do is to collect like terms. Those values that are similar, you bring them together, you leave behind on this other side what you're looking for exactly. So as it is now, if you collect like terms now, collecting like terms. So 10. Once minus 7 goes over across the equality sign, it becomes positive. Once this one goes over this side, it becomes positive. If here is positive before, once it crosses to this other side, in the process of collecting like that, it becomes negative. But this one is having negative, so if it crosses the other side, it becomes positive. So what is 10 plus 7? It means 17. So find the x. If you try to do another one, let's try another one quickly. Let's say, for instance, you have something like this. Solve 3x equal to 12. So we are looking for the unknown, which is this x. The 3 is having a coefficient of x, and then you have the 12. I don't want this 3 here. I want, at the end of the day, x is equal to something. You can do it in two ways. You can divide both sides by 3. So that at the end of the day, what you will have left here will just be x. Or you make x as a subject of formula and the rest. So we're going to do it in two forms. If I divide both sides by 3. So you now have something like this. 12 over 3. So 3 in 3 you have 3 in this one. So at the end of the day, 3 in this, you have 4. So this is one part of solving this. You can equally solve it. Or you make x as a subject of formula. So if you make x a subject of formula from that expression from that equation above, so the 3 will go to the denominator. When you make x a subject, the constant 3 here that's attached to the x, it goes to the denominator. So we have 3 as the denominator. So if you cancel this, at the end of the day, you have 4. It's the same. It's similar to this. So let's try another one. What if you have something like this? Solve 25 minus 9x equal to 2. This is also an equation because it's having an equality sign. You have a constant, you have a variable attached to 9, which means this 9 is having a coefficient. Then you have a constant again. So what you need to do is to just collect like terms. Solution. If you collect like terms, this constant will go and meet the other constants. So you have minus 9 equal to 2. Once this one means plus 25. If it goes to the other side, it becomes minus 25 because it's having a positive 25 here. So if you cross to the other side, you have minus 25. So you have, if you minus this, 2 minus 25 is like impossible. So at the end of the day, what you'll be having is minus 23. Minus 23. So you have 9x. But what we are interested in is to find the unknown, which is x. So I don't want this 9 to be here. I just want the x to remain. So I divide both sides. By 9. So if I do that, I'll be having 9x over, that is divided both sides by minus 9. Minus 9 was 23 over minus 9. Minus will cancel minus. 9 will cancel 9. So how many minus will cancel minus? How many 9 can you have in 23? You can only have 2 whole number, 5 over 9. So that is the answer. If you choose to confirm if this one is correct, check it. 9 times 2, you have 18. 18 plus 5, you have 23. That is how we got this very value. So let's go to another aspect. Unknown on both sides. Unknown on both sides. Unknown on both sides. So we solve this. Solve 5x equal to 4 equal to x. So just understand the first principle. It's the same. If you understand the principle, no matter how large the equation is, you can just bring them together. So the first thing you do is to collect like terms. Those ones that are similar, this and this will be on one side, will be together. This one and this one, which is a constant, will cross over to the other side. I like these 2x to come on this side, since at the end of the day, we'll be having x equal to something as our answer. So I would prefer it to come on this side. instead of this one going to meet that side. So I want it to come on this side. So if I collect like terms solution, so solution collecting like terms, so I have 5x. If this crosses, remember what I said earlier, once this is positive 2x, once it crosses to this side, it will be carrying minus 2x. So I have this 11, it's positive 11, so it's like there's an invisible positive here. Once you have a number with no operator written there in front of it, it definitely means that that very constant is positive. So as this one is positive 11. So this is actually going to this other side. So once it crosses to this side, it becomes plus 4. It is no longer minus 4. So if I work with this now, 5x minus 2x, I'm going to have 3x. If I add this together, I'm going to have 15. So remember what we said earlier. So if I want to divide both sides, it's back to what it was before. Divide both sides by 3. So if I divide both sides by 3, so I'll have something like this. So 3 in 3, nothing, as in 1. So 3 in 15, I will have 5. So this is lesson 1. So this is lesson 1. We'll continue from here. My name is Godwin. So put your comments for any questions and answer. I will respond to that. Thank you.